Hello, I'm talking to you. I wanted to give you the answers to the Chapter 5 Plug and Chug for practice um, and show you how to do the work. First off, the first thing I want to tell you is since we haven't talked about this formula at all, you don't need it. Um, and this formula is actually a variation of these two formulas. So it's just, if you wanted to get the a by itself, what would you do to this formula? Divide both sides by m, and hey, look what you got. So it's just a little bit of a rearrangement, so don't get all like in a twist. Now, last chapter, we dealt with the acceleration due to gravity. Now we're going to have different accelerations, and we're going to have to calculate what they are. So let's get started. Using five-part problem-solving method, calculate the acceleration of a 2,000 kilogram single-engine airplane. Well, kilograms is a unit of mass, so the mass is 2,000 kilograms. You cannot trade masses for newtons, masses for forces. They are not interchangeable at all. And it says airplane just before takeoff when the thrust of the engine is, so the force of the engine is 500 newtons. Awesome. So since we're looking for the acceleration, why don't we use this formula because it will give it to us directly. So we have the force, which is 500 divided by 2,000. And when you do that out, you get 0.25 meters per second squared because it's an acceleration. And we get, because acceleration is a vector quantity, we have to say what direction. And we can't really, it doesn't say to the right or to the north or anything. So all we can say is down the runway. Okay, so that's the first one. The second one, whoop, go, is a little bit tougher because you have to use a net force. So calculate the acceleration of a 300,000 kilogram jumbo jet. Well, that's a mass, equals 300,000 kilograms. Just before takeoff when the thrust of each of its 4 engines is this. So if we wanted to figure out the F net for this, you have one engine that's 300,000 and 30,000, but you have 4 of those, so you would take 4 times 30,000. You do that because the thing has 4 engines and each of them is putting out 30,000 newtons of force, so 4 times that, it actually equals 120,000 newtons. And again, we're looking for the acceleration, so we'll use that formula. So we have acceleration equals 120,000 divided by 300,000. And when you do that, the acceleration is 0.4 meters per second squared. And again, down the runway. Okay. The next one, whoops, sorry about that. I didn't mean to rock your world there. The next one, Lily pushes a 2 kilogram bag of flour, so the mass is 2 kilograms, across a horizontal friction-free floor with a horizontal force, so the force equals 20 newtons. Calculate the acceleration of the bag. So let's do A equals F over M. So A equals 20 divided by 2, so this gives 10 meters per second squared horizontally, because that's the only direction we're given. Now, a little bit different take on that simple problem is now we're going to add a friction force of 4 newtons. So if we'll draw a little free body diagram here, we got 20 newtons going in this direction, and we have 4 newtons going in this direction. What's the net force on this thing? Well, it's whatever's going in this direction minus what's going in that direction. So F net equals the force applied minus the force of friction. So in this case, it's 20 minus 4, which is 16 newtons. We know from the A part of this problem that the mass is 2 kilograms. Formula, same deal. Oh, we're looking for A equals F over M. So we have 16 divided by 2 equals A. So that's 8 meters per second squared. And again, the only direction we're given is horizontally. Really important that you put directions on these accelerations. All right, close your eyes for just a minute. I got to flip the page over and move the camera. Okay, here we go. So calculate the horizontal force that must be applied to a 1 kilogram bag of frozen peas. So mass equals 1 kilogram. To make it accelerate with a horizontal friction on a horizontal friction-free air table with the same acceleration it would have if it were dropped and fell freely. You know what that is. The acceleration is going to be 9.81 meters per second squared, but instead of being falling, it's going to be horizontally.
Could sophomores with last name beginning U through Z please come down to the media center with your devices? Thank you.
And that was a message from our sponsor. So when we do this problem, the FMA formula would be easier because FMA gives you the force directly. So we're going to say F equals 1 times 9.81, and that's going to give us 9.81 newtons, and we need to know the direction, and that's horizontally. All right. So a variation on that one, calculate the horizontal force that must be applied. So we're looking for force applied to produce an acceleration of 1.8 times the acceleration due to gravity. So that's 9.81. When you do that out, you find out that it is 17.66 meters per second squared. And we have our mass is 1.2 kilogram iguana. So again, the FMA would probably be easier here. So we have F equals 1.2 times 17.66. And when you do that out, it comes out to be 21.19 newtons, again, horizontally. Okay, well, that's going to do it for these problems. I hope you got them all right. If you didn't, I hope that you understand why you didn't get them right. Thanks for joining me. Have a good day.